There are several important mechanisms, four actually, that we need to consider when looking at nephron function. First of all, we need to make sure that we're really clear about what compartments we're talking about when. We've drawn a nephron. So you have an idea that a nephron is just a tube. So let's go ahead and draw what that tube actually looks like. Do you agree that the tube is going to be lined with cells? And in fact, the type of cells is going to vary depending on what part of the tubule we're in, because the structure of those cells is going to enable the function of those cells. Sometimes, no, all of the time, the cells lining the nephron tubule are epithelial cells because they're lining spaces. Do you agree that I could draw in like a little opening of my tube, and then this could be any part of the nephron at all? Do you agree with that? And here's my lumen of my tube, and this is where my pre-P is. And then do you agree that the tubule is associated with a blood vessel? But let's draw a blood vessel, doggies, because we know that blood vessels are lined with simple squamous epithelium, and that was the whole endothelial layer of my blood vessels, and these are all capillaries that we're talking about, so they're really, really thin, and you're cool with this. That's a little bit of a wonkiness. Wonkiness happens every now and then, but just a different structure. We're cool with this, though, right? Inside my blood vessel, we can just visualize that, yeah, this is what's going to be in here in the lumen of the blood vessel. I know it might seem obvious to you, but dogs, there's blood in here. What's inside the nephron tubule? It is not urine, and it is not blood. Bloody hell, it is not blood. It's called filtrate, and you can call it filtrate because that's what it's called. You can think of it as pre-P. It's not urine yet. It's filtrate. It's different. We're going to do some stuff to it. And then, of course, if we're going to move stuff between the blood and the filtrate and back again, we're going to have to cross an interstitial space, and there's fluid out here as well. These are the three compartments that become significant when we look at how this whole process is going to work. Now, if we take stuff from the blood and we move it into the nephron tubule, we take blood stuff and make it into filtrate. That is called filtration. You're cool? Filtration, if something is not going well, you could filter out blood cells, but most of the time, the blood cells stay in the blood vessel. But how many layers of cells did we actually have to cross? We have this entire layer of endothelium for the blood vessel that we had to cross. We have to cross all this interstitial space, and then we have to cross another layer of epithelial cells to get into the lumen. Sometimes filtration gets stuff out that we want back. And so sometimes we can reabsorb stuff into the blood. Apparently that was a more difficult direction to draw my arrow. If we move something from the filtrate into the blood, this is called reabsorption. Reabsorption. They're the same essential process in opposite. Filtration is very general. Filtration is like, dude, let's just take anything that's in the blood and we'll throw it into the filtrate. There's another process that is extremely specific. That's an arrow right there, and it makes me think that, okay, look. If I have a very specific thing, not just mass movement of stuff via filtration, but if I have something really specific that I want to take and dump into the filtrate, do you see how I made my line really straight to show you that I'm being very specific and deliberate about taking this thing and putting it into the tubule? If it's specific and deliberate, it is called secretion. Secretion happens from blood to tubule. Secretion does not happen in the opposite direction. If it happens in the opposite direction, it's reabsorption. The last process that takes place in the last major function is this one. Anything that is left in the collecting duct that does not get reabsorbed back into the blood, that is going to be excreted. So this process is excretion. Okay, don't ever forget about this. Like, keep this picture with you at all times. We could go back. I think back is up. It is. We could go back to our, no, I want the one that has the blood vessel on it. We could go over here, and I could say to you, okay, doggies, I want to know, I've got something here, and I make it go there. It started in the descending loop of Henle, and now it is in the vasa recta. What did I just do? That's reabsorption. Do you agree? We just reabsorbed it into the blood. If I have something here in the glomerulus, oh, and now it moves into the nephron, that is filtration. If I have something very specific, I'm going to throw my color in there. Here's my very specific thing that I am very specifically dumping, secreting into the nephron. That's secretion. Look at this. What if I take something from here and take it this way? Look, my arrow's in the opposite direction, but I'm going from filtrate to blood. That's reabsorption. The reason why I'm showing you that is because I don't want you to forget that the direction matters. Look at this. What if I go from here out? That ultimately, hopefully, will be reabsorption. Or else if you left all your fluid and stuff out here in the interstitial space, what would happen to your kidney? It'd explode. That would be terrible. Please don't have exploding kidneys on my watch. This might be the best diagram that I've ever made, ever, for kidney function. Remember that for forever. Now, let's talk about what happens in the renal corpuscle. Which of these functions is going on there?